Let's move on to another operations, and now let's discuss how to carry out dot product of two different vectors. Okay, so as you can see here, what we have done is we have defined two different vectors a and b. Each of these vectors have four elements, right? And we want to do a dot product of these vectors, right? So again, using np dot array, and one way to define a vector is not have the second row or the third row. Only one row of the np dot array could be used to represent a given vector, and that's what we are using here. So rather than having multiple different or two or three different square bracket, you will see that we are representing the vector a using only one square bracket when we are calling that np dot array function. So using np dot array, we can also represent vectors, we can also represent matrices, but when we are representing vectors, essentially we will need one set of square brackets that is there. Okay, so you can see that the command a, the first line of this right here, helps us in defining the vector a, and then the b variable basically stores the vector b, and that's where we define the vector b. And again, the np dot a comma b is the function that we use to take the dot product of two different vectors a and b, right? And so when you carry that out, that essentially will help us in computing the dot product of two different vectors. So two different vectors are here. Let's execute this command and see what comes out of this. So we have this vector a and b, and when we take a dot product of this vector a and b, the output is going to be minus 31. So this is how you can compute the dot product of two different vectors in a Python framework, programming framework. So let's move on, and again, since we are continuing on vectors, let's also define how, or also see how vector cross product could be implemented in Python. So we have these two vectors u and v, and we want to take the cross product of this vectors u and v, right? And this is essentially performed by numpy function known as cross and in the round parenthesis. So what you see here, that now we are defining vectors, and again I want to repeat, when we are defining a vectors, we can still use np dot array, which is also used to define matrices, but in this case what we will have is we will essentially have only one set of square bracket that could be used to represent only one row of the matrix, and which corresponds to essentially a vector, right? So that's what you see. So you can see we have used this variable u and v to represent the two different vectors that we have defined here. So if you look into the vectors, which is like 1i plus 2j minus 2k, that's u vector, and then the v vector is 2i plus 1k. So to represent these two vectors, we have used the variables u and v in the Python using np.array, and that's what you see here. And now if you want to take the cross product of this two different vectors, which is different than the dot product, we have used the variable uv to represent and store the value that will come out of after doing the cross product of two vectors u and v using the numpy function cross. And so we will use np.cross and then round parenthesis u comma v, and that essentially function will help us in computing the cross product of the two vectors u and v. Okay, so again, let's execute this and see what comes out. So we have these two different vectors a and b, and when we took the cross product, that cross product vector came out to be equal to 2 minus 5 minus 4. So that's the output. So essentially u cross v will be 2i minus 5j minus 4k. That will be the output vector, which is a result of the cross product of the vector u and v. Let's move on to another important concept that we have learned in the previous lecture, which is how to solve a set of linear equation using matrix operations. Now let's revisit that problem and see how can we solve a set of linear equation using Python. So what you see on the screen right now is essentially we have a system of linear equation, and this is essentially three variables, three equations that has been listed here, where we have three unknowns, and for each of and we have three equations. So the first thing that we need to do is take this set of linear equation and represent them in the matrix form, right? And this is something that we have discussed in the theoretical portion of the lecture, that how can you take a system of equation and write that in the matrix form. So from this set of equations, we arrive at the matrix form, which is given here. So we have this matrix 2, 6, 5, minus 5, 6, 12, and 4, 5, minus 3, that is multiplied by the vector x, y, z, and that is equal to a vector 10, 13, 25. And this is essentially a vector representation of the three equations that is given on the top. Okay. Now, if you want to solve this using Python, how do we do that? In num5, we have a function called solve in the round bracket, and we will basically call that function, and this function essentially helps us in solving the this problem, which is basically solving the three unknown and finding the value of the three variables that we have. So what we do here, in order to implement this, first thing that we need to do is we need to represent the matrix, which is here. So we will store the matrix on the left hand side that you see right here as a matrix A, and we will store the vector which is on the right hand side, the vector 10, 13, 25 as B, and then we will call the solve function where we will provide the value of A matrix and the B vector, and then this function will automatically solve the set of equation and provide the values or the solution of the set of equations that we have. So if you look in the command that we have begin with defining what the A matrix is using np.array, okay, and then we have also used the np.array to define a vector B, which is on the right hand side, which is 10, 13, and 25, and then we are defining this line which is xyz is equal to np.linalg dot solve, and in round parentheses round brackets we have A comma B, and we are providing the A, which is the matrix, comma B, which is the vector which is on the right hand side of the equation that you see above, and then this will help us in essentially solving this problem or finding the solution of this set of equations using Python programming framework that we have. So let's execute this and see how this comes out. Now, if you execute this, the value of the solution that came out for xyz is listed here, and x was equal to minus 4.08374, y is equal to 6.07389, and z is equal to minus 3.6551, and so on. Okay, so this is how you can use the function solve in the NumPy to solve a set of equation. The key thing that you need to mindful is from this initial set of equations that you have to essentially convert that into a matrix form, and then use that as a representation to define what matrix A is and what vector B, which is on the right hand side of this matrix vector form that you see, and then from there you can essentially define those initially and then call for the solve function, and once you call the solve function, it will allow you to essentially solve the equation. Python will solve the equation and give you the values of the variables that essentially satisfies all the three equations that you have.